Hello everybody. Just wanted to wish you a Merry Christmas from Tim, Howie, and myself, and thank you for all of the well wishes and holiday greetings on my last video, Bright Idea. Hello everybody, and Merry Christmas to all, 2017. So I'm going to show you what my tool idea was. Maybe I'm going to lose a lot of money here. I don't think so though, but we'll talk about it. So let's start with a Kant Twist clamp. Go on, Howie. Howie, go lay down. Howie wants to say Merry Christmas. Maybe we'll get him in here later. Go lay down, buddy. So a Kant Twist clamp. Quick way to adjust it. Spin the little guy, right? Yeah, works pretty good on a small one. Quick adjust. Pretty good, huh? Yeah, we get up a little bigger. Yeah, we can still do it. This is a it's a 3 inch Kant Twist. Works pretty good. Well, get up to a 4, and well, maybe with some practice you can get it down. I guess I need a lot of practice. 4.5. And this guy is a 6, and a 6 is, I can't do it, okay? Well, you know, to adjust this guy, sit there and spin it like that, it takes time, right? Yeah, if you're doing this once, you know, for one setup to clamp down, yeah, not a big deal, right? If you got to open and close the jaw. If you were doing multiple setups, where you were having to move the jaws a lot, yeah, that's a lot of time. Well, what got me thinking about this was when I did the review of the diamide clamps. They have a detachable hand wheel so that you can actually fine-tune or open and close the unit. This is a 5-inch unit, and you could see that would take quite some time to open that guy. But of course, it's designed to use with an impact wrench. And very quick to open and close, right? Sweet. That's the 5-inch. And the big guy, the 8-inch, I mean, that would be some time to open that by hand, right? Nice and quick. So demonstrating these got me thinking about it, about the use on the Kant Twist clamps and subsequently C-clamps. Again, the C-clamp, you're going to take some time. I don't think you can wiggle these around either. So that's what is this guy? This is it's a 6, so 6-inch, taking quite a bit of time. So it got me thinking about it. Well, why can't I make a driver for the Kant Twist? So you'll see there's a variety up here we'll talk about. So this was the first one I roughed out with my idea, and my thought was to cut a hex on the end of this so that it could be used in a drill driver. And I had set it up, and I think I'd showed this on either Facebook or I don't know, the video. If you notice it's chewed up. Well, I've set it in the mill, came in, and the mill caught it, the tool caught it, and I knurled the top of it there. So I goofed this one up. Okay, lesson learned, that was a bad idea. But it was designed to fit the 3-inch, the 4.5, this is the 4.5 Kant Twist. Being that it'll fit the 4.5, it'll also fit the next unit down. No, I guess it won't. I've written all the sizes of these. Okay, so it didn't fit the 3-inch. The diameter on the end of this Tommy bar piece is a different dimension, but yet it'll bite on the Tommy bar. So there, and of course it's too small for the bigger one. So we go on to the next rendition, which is this guy right here. And hey, not bad. Cleaned it up, and this one will fit the biggest one. Fits real nice, but uh-oh, Charlie had a bozo. Charlie was going so fast putting the hex on it that I goofed up on the math. So although it works, it'll fit in a drill driver, it was a slow down, Charlie. The other thing I was experimenting with, and this has it, and you won't be able to see it, but I was looking at different dimensions in the cup. Since these heads are different, I was looking to see if I needed to put a smaller cup dimension deeper in for the smaller unit. Really doesn't matter. So, yeah, we go on to the next one that I made. What was wrong with this one? Notice I said wrong. This one wasn't deep enough. I was still fooling around with depths and stuff. And when I do these things, it fits on that one. I don't draw, I don't measure, I go pretty quick. So that's another fail. This one, hey, that one looks really nice. Uh-oh, what'd I do this time? Well, I didn't have my depths correct. So the bottom of this guy is probably, oh, I don't know, 30 thousandths. Not much left in the bottom there. So I was starting to hone in on my dimensions, and fits the larger one really nice, and it fits this 6-inch C-clamp. All right, let's go on with my builds. Hey, here's one. Nice, nice. Fits the drill driver. Plugs right into the drill driver, and we're off to the races. Pretty sweet. Works great. Works great. Opens and closes C-clamps. I'm liking it. Yeah, but Charlie got it in there crooked. So we go on to another one. Oh boy, the trials and tribulations of R&D in the home hobbyist shop. So we go on to the next one. Oh, this one turned out just great. Just perfect. But Charlie had to put it to the test. So what I was doing here, do I have it? Yeah, I got another one here. These driver bits, you can buy 8 of them for, I don't know, $2 or something. It's much simpler to cut one of these heads off. And I was, instead of broaching at this point, I was turning down the diameter. And that's why when you watched my first video that I had a specific hole size in that drill, and then I was turning the diameter down and pressing it in to the end. So this guy got pressed in, and either the weld or I think I pressed it in crooked, to be honest with you. That's pressed in, and then it's got a weld in there. So back to what I was talking about. So this guy, geez, I did a nice weld in there. Beautiful. It's concentric. So I was running the tools back and forth, trying it, and then I said, well, okay, now let's take it a step further. Can we use it like the diamide? Can we actually tighten down a Kant Twist clamp or a C clamp with it? Hey, that's good thinking, Charlie. So, of course, I took a Kant Twist clamp. Hey, sweet, worked really nice. Checked the Tommy bar to see, since I really hadn't deburred this much, I wanted to see, and it's not hardened. You can probably even see the little bit of distortion right there. Looking at the Tommy bar, did I damage the Tommy bar at all? I think it was this guy. Yeah, you can see a little marking on the Tommy bar. I hadn't checked what these, I think these are mild steel. I ought to check it and see what they are. So, all right. So, okay, hey, let's try it on a C-clamp. Put the C-clamp on there with this little 1/4 inch drive impact. Hey, it's tightening nice. Snap. I got my lesson in metallurgy. There it is. Of course, this driver's hardened. When I TIG welded that into the cup, I changed the characteristics of this and snapped it right off. So that left me at a point where, okay, I think I got a bright idea. Is it a marketable idea? And I kept saying I was going to build 50. Well, I was planning on building 50 and send probably 30 out to my YouTube buddies as a gift, as fun, and then put some on eBay, see if I can sell these. And that was the question. Okay, what would somebody pay for one of these? I kept coming up that I want to be somewhere around 20 bucks. Yeah, why would you pay 20 bucks? I don't think it would sell for 20 bucks. Probably right around $13 is where it would go. So I don't think I can produce them fast enough to make it worth my time for $13 a sale. So I started falling away from the idea. And I had some help from Blue Hands Video, Mike Klotz. I'll cut in a couple of photos here of the modeling he did for me. He did a really, really nice job on the modeling. Thank you, Mike. And then I got a call from Stan Zinkowski, another bud. And of course, I started talking with him, and he's a heck of a knowledgeable source also. Oh, I got to drop backwards. The whole idea of using the drill driver ends was Mike's idea. I was trying to do this originally, which is a lot of time to turn all that down, especially when it's 875 thousandths down to 1/4 inch. So Mike came up with the idea of putting the drill driver stubs in. Hey, that was a great idea, Mike. And subsequently I talked to Stan, and we were chatting about it, and he's a good source of information, and we were chatting about it, and he goes, well, you know, they do make those. And I said, huh? And he goes, yeah, they're called wingnut eye bolt drivers, and also hurricane screwdrivers. And then there's also something similar that's for the track that electricians put up. I can't think of the name of that stuff. So anyway, as you see, I got one. So I bought one, said, okay, well, the heck with building these things. Throw that idea out. So I bought the unit from Ryobi, and this ordered from Home Depot was about 10 bucks. Now there goes my $13 idea. It's hardened. I've checked it. It's about it's over 40, under 45. Checked it with the files. And two issues with it though. The bore is too small, and the outer diameter is a little small. The outer diameter on this is 775, and I really like 875. So about 100 thousandths off. So if I bore this to open it up, I'll end up with about a 70 thousandths wall thickness on each side. Probably good enough to drive it open and close, but not to hammer the guy home like I was trying to do where I broke this one. Yeah, maybe. I think we'll probably try it. What the hell? So, with that said, I've got a little boring bar here, one of the Banggood purchases that I did. a whole set of these boring bars. We're going to put it to a test here. We'll go in and open up the bore on this guy, and then the Tommy bar slot, it fits the 4.5, and it fits the 6D, a little tight. Just a little cleanup in there with a grinder would, it actually fits. It's nice and tight. But it doesn't fit the C-clamp. I'd have to open it up even more. I might even do that. So let's we'll go over to the lathe and take a look at doing this, and then bring you back for some testing, I guess. And in retrospect, in the final discussion here before we go on, is like I said, if you're just going to use one clamp, it's that far open, and you're going to tighten it down, yeah, it doesn't take that long to do that, right? And I've been thinking about this in a shop. If a shop had jigs set up where they were holding something down repetitively, well, they'd have that clamp for that unit, or they'd have pneumatic clamps. But if they didn't have pneumatic and they were using C clamps or the Kant Twist, they would have pretty much dedicated if they're in any kind of production. If you're in a non-production setup where, at one point you're clamping this, and the next point you're clamping this and here, and you're moving these, maybe my driver idea has some merit. Save a lot of time. Time's money, right? And I've been thinking about it. I just don't know that it's a marketable tool for the machinist community, because I don't think people are adjusting their Kant Twists multiple in a setup if it was production. So anyway, enough said. So I think my great idea is another dead one. I've had a lot of great ones. I got another one up here on the shelf. I'll have to share it with you. Okay, let's go over to the lathe and see what happens when we try to turn this guy. Okay, got you here over at the lathe. I'm actually running the camera here so I can see it on my iPad. And I had some guys report in the past that when I had done that, they could hear a hum. Well, I don't know if you can hear a hum or not. I haven't turned on anything yet, but it's going to get noisy. So let's give it a go. I hope that view works for you. I don't think it's the greatest view, but we'll give it a try. All right, let me go get some power on. So as I mentioned, this part is it's under 45, over 40 in hardness, and we're trying the Banggood boring bar on this guy. It's got a little insert in it. I'm going to just try touching on the outside. It's an interrupted cut too, which is no bueno. Making contact there. Let's try like 5 thou. Little hand feed, see what it does. That's cutting it. second shoulder in there. I think I'm hitting it right there. Yeah, hitting that right there. Pretty big cut to take that. Yeah, let's try it, see what it does. Just feed it by hand. Little Banggood's doing good. So I need to go about 3/8 deep. So right there. Yeah, hit it. Feed by hand. Another 100 thousandths to go. Starting to push a piece over. Yeah, we're getting into a deeper cut there. At the base of the radius of the tool. As old my buddy Harold Waters says, you guys take a nap for a second, okay? Okay, you guys awake? So just checking the bore with the gauge pin where I'm at, and I'm at 481. So we'll set the DRO to 481. Enter. And my goal is 630. Write that down, I'm an old bastard, I'll forget. So let's take about a 20 thousandths cut. see how she does. Yeah, let's check her feed first. What do we got for feed? Yeah, pretty aggressive on the feed. Yeah, let's try it. Interrupted cut, let's give it a go, see what she does. Pretty hard. Okay, 340 thousandths in. I'm going to set a stop over here so I can see it coming. We'll clean that up after. Try another 20. Be nice to it, give it a little juice. Hey now! Well, I got rid of my burr. That was a screw up, Charlie. It worked up. And the boring bar held. What did I do there? Charlie, thinking of you guys. Too many things. Okay. The boring bar did a nice job. Son of a buckaroo. You have to cut that out, you guys. I don't know if I want to see you guys laughing too hard. We went by the zero by a bit. All right, zero there. Come on, zero out. Okay, let's go back at it again. A little exciting moment there. Let's take another 20. What happened here? Just checking here what went on. Okay, there's bottom. finish this by hand, guys. Now let me double check where we're at. Should be at 601. $5.99. $5.99, no go. I don't think my crash there helped anything. Okay. So we're at 565. We're going to 630. Tips looking okay. That's 600. Split it in half, go to 615. Let's give it a check, see where we're at. Should be 615. Now there's the 615. No, I think we're getting a little too much flex on these key. 610. You know something? Let's do this. You guys go to sleep, I'm going to change the feed down. Alright, wake up. So, just for talking purposes, spinning the chuck at around 600 RPM, and My feed there was 8 thou per revolution, and I just cut it down to about 4 thou revolution. So let's do just a cleanup pass, see what we get. Something's happening over here. Not good. I'm missing my disengagement or something here. Hang on. All right. Enough excitement. Jiminy Christmas. It's always on camera. I'm trying to do too many things. So what are we at? Should be at 610. $6.11. All right, our target is 630. Take it to 625. I see what happened. So that power in this machine, and it pushed the actual tool back in the chuck. I just noticed that. All right, 630. Okay, well, done machining on this guy, and I had to go back, bore deeper. Luckily, I had a carbide bit that I could get in there and make it deeper, but I got it to fit. So it fits the large Kant Twist, and it fits actually even the C-clamp. It would, you know, I could have made a bunch of those as fast as I could have machined this down. But it's hardened though, so it would really be nice if these little slots weren't there, although they'll work on the little Kant Twist, even though that would turn the little Kant Twist. But it would certainly be nice to have a whole half round there to hammer against. But hey, let's give it hell and see what happens. See if we break it. Can always go back and make one of those and not use it as a driver. So let's go ahead and go with the big guy. Let's see, better put these on just in case. Okay, here goes something. Huh, not bad. Can I tighten it more by hand? I can't tighten it any more by hand. Winner, winner, chicken dinner. Hey, let's try that again. Okay, there is some marring here on the Tommy bar. I probably could have went and polished that a little better. But winner, winner, chicken dinner. I like it. I can get a little more out of the C-clamp because I got a bigger, maybe a little yield out of the C-clamp too. Okay, Merry Christmas, you guys. Somebody will probably steal my idea and make millions. But I think I'm out of business. I'm not making any more of those, and I'm not going to retrofit any more of these for anybody. If you want to do it, it's the Ryobi Wingnut eye-bolt driver. $10 and a little bit of machining, and you got something that works. All right. There may be some little bozo moves that I'll put here at the end of the video. I don't know if I left them in the video or if I'm just going to leave them here at the end. I haven't seen them yet, so I don't know if I want to show them to you or not. A couple of mishaps on the lathe, and we'll see. But with that said, Merry Christmas, guys. Something's happening over here. Not good.